Let's check that this method actually gives us a number that makes sense when we have a look at it with whole numbers. Now we can see here that if we're on the ball with what we were looking at before, we can see that we can just multiply the whole numbers there, and we can multiply the surd parts there, so we get 4 root 36 like that. Now we know that 4 root 36 is 4 times the root of 36, which is 6, and so this should give us 24. So the actual number answer to this sum, this one here, is 24. So let's have a look at the breakdown of that. I'll use a different color. Let's break this up into pieces. So 2 times the root of 4 times 2 times the root of 9, and what that should give me is 24, because we've just shown that it's worth 24 according to the method we're using. Now 2 is a 2. The square root of 4 is also 2. We've got another 2 there, and the square root of 9 is 3. Now that should equal 24. Let's check. 2 times 2 is 4, times 2 is 8, times 3 is 24, so we get 24 equals 24, and all is right with the world. No worries, so the method's good. If we apply some crappy version of the method, such as just to do, we've got 2 root 4 times 2 root 9, and we just do something stupid like, it's 2 times 4 times 2 times 9, and maybe stick a root sign over the whole thing just to be slack, we get 8, 16, what's 16 times 9? 54, 144, and that's equal to 12. And so this 12 does not equal 24. So any method like this, where we're just doing random multiplications, sticking a root sign over it or not, doesn't make any difference. This is not the correct method. This method of breaking up the pieces, of putting the two whole numbers together, then putting the two surd parts together, works to give us the correct number answer.